to graph a hyperbola. The things you want to start with, you want to write down some of these things. You want to know what your center is, because that's where we're going to start when we are graphing. We're also going to want to know the values of A, B, and C. So let's look at this. Notice the y squared comes first. That tells me this is going to be a vertical hyperbola. Okay, it's going to go up and down. It also tells me that this is b squared goes with the y, and a squared goes with the x's. Okay, so if I take the square root of that, I know that b, I'm going to write this somewhere else. I know that b is the square root of 64, or 8. I know that a is the square root of 36, which is 6. To find c, we use this formula down here. C is the square root of a squared plus b squared. So c would be the square root of 64 plus 36, which is the square root of 100, or 10. Okay, so we know a, b, and c. We know our center by looking at this. And again, this is super easy to mix up. Remember, x coordinates go first. So first, when you're writing your center, write the value that's with x. Change the sign, though. So we have positive 2, comma. Y didn't have anything added or subtracted from it, so the y coordinate of my center is going to be 0. So as I start graphing this, I know I have a center at the point 2, 0. Okay? I also know that this is a vertical hyperbola. Okay, so it should be going up and down. So to put my vertices, each vertex on, I'm going to use my b value. I'm going to go up 8 from the center. Put my vertex. Go down 8 from the center to put the other. Okay, so notice my vertices are changing my y values, but not my x values. So my vertices are at 2, positive 8, and 2, negative 8. I added and subtracted 8 from the y value of my center. The foci, or the focus point, I use my c value. Again, this is vertical, so my x value is not going to change, just my y value. So for my center, I need to go up 10, which would give me a positive 10. So the point 2, positive 10 up here. And if I go down 10 from the center, I get to negative 10. Okay, so there's my vertices, my focus points. The asymptotes, the way that I typically do this when I teach this is to use that other coordinate, the A, and go horizontally. So, okay, and it's not really a point on the graph, so you just want to kind of mark that 6 to the left and 6 to the right of the center. Okay, and then we're going to form a little guide box or rectangle going through the vertices, okay, and those A values that we just marked. Okay, the asymptotes, when you're drawing them, should go through the corners of that rectangle and through the center. And what these asymptotes do is they guide each, whoa, I totally missed my center on that first one, didn't I? Is they guide you, okay? Okay, so they kind of guide you as you're doing this, drawing each of your pieces of your hyperbola. Okay, and the sections should go through the vertex and follow those asymptotes. So this would be the top of my hyperbola, and down here would be the bottom of my hyperbola. Now the equation, you can use this down here. So my asymptotes, their equation is going to be y equals plus or minus b over a. So b over a would be what? It would be 8 over 6. I do want to reduce that as much as I possibly can. So that would give me 4/3 then. So plus or minus 4/3 x minus the x coordinate of our center plus the y coordinate of our center, which is 0. And you don't need to put that 0 on there. I just put it on there as a marker so you wouldn't know that we don't just leave that part off. Okay, so I've graphed this hyperbola and I've identified each of its parts. All right, let's try another. Okay, so again, the things you want to identify before you start is your center. And again, be very careful. The x-coordinate of your center is the one that goes with x. It does come first this time, so -1 and +2 for our y. We want to know a and b. A squared is underneath the x value, so this is my a squared is 16, and my b squared is 9. So a would be the square root of 16, which is 4. B would be the square root of 9, which is 3. And to find c, we do the square root of a squared plus b squared, just like we have down here, which would be 16 plus 9. 16 plus 9 is 25, and the square root of 25 is 5. So my c is 5. C is the distance from the center to your focus point. Okay, so that's what we're going to use it for. So let's start a graph here. Okay, so our center right there at -1, 2. Since x, notice this x is the portion or the first portion of our hyperbola, this tells us this is going to be horizontal. Okay, so let's do those x values first. We're going to go 4 to the right and 4 to the left of the center to put our vertices. So our vertices, since this is horizontal, it's going to make changes to the x-coordinate of our center. The y is going to stay at 2 when we write our vertices. The x-coordinate, we're going to add and subtract 4 from it. So -1 minus 4 would give me the point -5, 2. -1 plus 4 would give me +3. So there's my vertices. My focus points deal with the value c. Okay. We're going to be adding and subtracting c from the x value of our center since this was horizontal. And again, I determined that by looking at the equation. Okay, so for my focus points, I want to add and subtract 5. Those red points there would be my focus points. So -1 minus 5 would give me -6, 2. And -1 plus 5 would give me 4, 2. So there are my focus points. Now to draw each section of the hyperbola, again, what I like to do is draw kind of a guide box. My b being 3 tells me that if I go up 3 from the center, and again, that's not one of my vertices, it's just kind of a mark I'm going to use, and down 3, this gives me a guide box, okay, using my vertices and those points I just found. The asymptotes will run through the center and through the corners of that rectangle we just formed, okay, our little guide box. Or you can use the equation of the lines and go ahead and graph those lines for the asymptotes. You'll get the same asymptotes either way. I just find that to be a little quicker than finding the equation of the asymptote. Okay, each section of your hyperbola should go through the vertex on each side and follow the asymptote. So that is what our hyperbola would look like. For the equation of our asymptotes that they wanted, it's supposed to be y equals plus or minus b over a. B was 3 and a was 4. That doesn't reduce at all. X, small coordinate of our vertex, which would give us x plus 1. So x minus -1 would be a plus. And then plus the y coordinate of our vertex, which was 2. Or our center, excuse me, saying vertex and it's the center. So there is our answers. All right, one last problem. This is going to have some roots that don't come out quite even because I know you'll probably have some of those on the assignment. So let's first identify our center is HK. And again, very carefully notice here's my x coordinate would be -4. My y coordinate is +3. I know that this is going to be a vertical hyperbola because the y is first and the positive term subtracting the x's. Okay, so this is going to be vertical. So when I write down my vertices, I'm going to be changing the value of the y part of our center. Okay. We need to know a, b, and c. A squared is underneath the x. B squared is underneath the y. So a is the square root of 7. B is the square root of 12, which if we simplify that, since 12 is 4 times 3, we get 2. The square root of 4 is 2, root 3 for our b. C is the square root of a squared plus b squared. So our a squared and b squared were 12 and 7. If I add those, I get the square root of 19 for C. So for my vertices, I'm going to add and subtract, since this is vertical, I'm going to add and subtract b from the y coordinate of my center. So my center will, or my vertices will be at -4, 3 plus 2 root 3, because that was my b value, and -4, 3 minus 2 root 3. Okay, the focus points, we use the value for C, so they'll be at -4, 3 plus the square root of 19, and the other will be at -4, 3 minus the square root of 19. Now I could go ahead and find the equation of my asymptotes without doing anything else, because I know that it's plus or minus b over a. b over a I can tell is going to use some simplification here, so I'm going to do that first over to the side. b over a is going to give me 2 root 3 over root 7. You cannot have a radical in the denominator of a fraction. It's not considered to be simplified. To fix that, you multiply the top and the bottom because it's by whatever is in that denominator. In this case, the square root of 7. That will fix our problem because root 7 times root 7 is 7, and our radical's gone in the denominator. And it's perfectly legal because notice, multiplying by root 7 over root 7 is like multiplying by 1, which doesn't change the value. Okay, it just changes its look. So what that does for us is gives us 2 times the square root of 21 over 7. And we're going to use that up here for our asymptotes. So the asymptotes will be 2 root 21 over 7, x minus the x coordinate of our vertex, which would be x minus -4 or x plus 4, and then plus the y coordinate of our vertex, which is 3. Okay, so there's all of my parts. I even found them. I didn't even have to actually graph it, but let's go ahead and graph it because I'm certain on the final you will be asked to graph things like this. Okay, and I don't want you to be just kind of stuck if that were to come. So let's go ahead and graph it. We start with the center, which is at -4, 3. Okay, this is vertical, so as we find our vertices, they should go up and down. I'm going to find out what 3 plus 2 root 3 is. It's 6.4. So we're at -4, 6.4. Okay, and 3 minus 2 root 3 is -0.46, so about -0.5. Okay, there's my vertices. I know my hyperbola is going to go like this in some manner. The focus points are at 3 plus the square root of 19, or 7.3, and 3 minus the square root of 19, which is -1.35. About there. to form our asymptotes, again, this is just the way that I typically teach this. You form a box with your vertices, and the b value is the square root of 7, which is about 2.6. So I'm going to go about 2.6 and make a mark to the left of the center, and 2.6, make a mark to the right, and form that guide box for my asymptotes. I do have equations for them, so you can use the equation. The asymptotes will go through the center and through the corners of that rectangle we just formed, and then your curves for your hyperbola should go through your vertex and follow those asymptotes. So there is a graph of that hyperbola.